Hey guys, welcome. We're going to start a new section today talking about ratios. We'll start with ratios and move on from there. This could be a super valuable topic, and very, very, very useful, kind of very fundamental to a lot of things. And not least of all is this idea of just getting comfortable with fractions. So today we're going to get comfortable with ratios as fractions, and basically what we're going to do is reduce fractions. That's what we're going to do. So we're going to have a ratio is just a comparison of two amounts compared together, two things compared. So 7 to 2, that's just a ratio. We can write 7 to 2 as 7 colon 2, or we can write it as 7 over. I said 2, didn't I? Oh my goodness, this is off to a bad start. 7 over 12, 7 to 12, 7 to 12, 7 over 12. Those are all equivalent ratios, equivalent forms of ratios. That's fine. Now you probably know that 7/12 cannot be reduced. That fraction cannot be reduced, so we're not going to be able to simplify it. Now let's do the next one. So 3.9 to 4.2, get my words straight. That's 3.9 to 4.2. Okay, there's one way to write it. But the more common way to write it would be 3.9 to 4.2. And if the question said just write as a fraction in fraction notation, so just write this ratio in the form of a fraction, that would be the answer. But of course, you know that we don't really like fractions with decimals in them, so we're going to do some work on this to make it not have decimals. So the first thing that I might do is I might multiply the top and the bottom by 10. And multiplying by 10, because we have a fraction in the tenths, we have a fraction, the tenths portion to our numbers. We multiply by 10, that's going to move the decimal over one space. This becomes 39 over 42. So that will be the first thing that we do. But then we notice that 39 and 42 can both be divided evenly by 3, so I'm going to reduce the fraction, dividing by 3, and I'll get, let's see, 13 over 14. I think that's right, and so that will be my answer. And 13 over 14 can't be reduced any further. All right, last difficult example, I think. Here we have 2 and 2/5 to 6 and 1/2. So I can write 2 and 2/5 to 6 and 1/2. I can write that as a fraction. I can write like this. I write 2 and 2/5 to 6 and 1/2. Now that's pretty awkward, having a mixed number in our numerator and a mixed number in our denominator. I could repair this a little bit by just changing those to improper fractions. And so we can do that. We can say 2 and 2/5. We take 2 times the 5, the whole number 2, and break it into fifths. How many fifths are in 2? Let's say 2 times 5 is 10. 10 fifths plus the 2/5 is 12 fifths. And then the denominator, 6 1/2. How many halves are in 6? Well, 6 times 2 is 12. 12 halves is 6. 12 plus the 1/2 is 13 halves. Okay, so we improved our fraction a little bit because now there's no mixed numbers, but we still have two fractions one in our numerator, one in our denominator. We need to remember that the rules for dividing fractions, and that's the key idea here, that this fraction bar and all fraction bars mean divide the top by the bottom. So top divided by the bottom. So we can rewrite this as 12 fifths divided by 13 halves. Means the same thing. And then you remember your fraction division rule is you just divide by a fraction means the same as multiply by the reciprocal of the fraction. So the reciprocal of 13 halves is 2/13. And then we can multiply across. So 12 times 2 is 24. And 13 times 5 is 65. And there we have it. I don't want to get too complicated here, but we know that we can't reduce this fraction because we know that none of the factors of the numerator and the denominator are the same. So the factors in the denominator, the factors at the bottom, were 5 and 13. 12 is really 2 times 2 times 3. And then, of course, we have a 2 here. So we have 5 and 13 are the prime factors in the denominator. 2 and 3 are the prime factors in the numerator. And none of the factors are the same, and so we can't reduce this fraction any. Okay, that's a really useful way to think about this. You can, if you want to, you can run through your calculator, divide 24 and 65 by the prime numbers in order, divide by 2, 3, 5, 7, 11, 13, until you discover that there's no prime factors that are the same in the numerator and the denominator. Okay, so that was a mixed number, a ratio of mixed numbers. Now we're going to talk about ratios of units, and this will be really easy. So 14 centimeters to 20 centimeters would be 14 centimeters to 20 centimeters. And we can reduce the fraction. I think we could just divide by 2. So top divided by 2 is 7 centimeters to 10 centimeters. And there it is. Now, this is a little bit of a funny thing to think about, but think about it. What did I just do? I said, well, 14 is 2 times 7, and 20 is 2 times 10, and I crossed off the 2's because they're the same factor. Well, could you think about this as the centimeters are the same and just cross those off? The ratio of 14 centimeters to 20 centimeters is 7 to 10. Well, we could think of it that way as long as we remember that we're talking about centimeters, but the ratio is the same if we converted the centimeters into meters or miles or anything else. So that's kind of interesting to think about, that we can treat the units as part of our fractions. And we can cancel out units just like we cancel out the factors, the number factors. So that's something to think about as we move down the road. But in general, we don't want to complicate this too much. We're just going to write our ratio as a fraction. $46 to $102. We can divide by 2. We get 23 to 51. And 23 is a prime number, so that is as far as we can take it. All right, thank you very much for watching. See you next time.